Okay everyone, welcome to one of the easiest C2 topics, the trapezium rule. And notice my spelling. You'll find out about that later. Okay, sometimes there are things that we just can't integrate to find the area under the curve, or sometimes we just want it to be an estimate. We don't need it to be absolutely exact. So if we have this, they're going to direct you to it by saying using the trapezium rule. So first of all, we're going to have a look at what's happening. And then I'm going to show you how to set it out in the exam. So first of all, what's happening? The first thing we're going to do is we're going to do a little sketch. And if we do a sketch, this is what y equals root x looks like. And we're going to integrate it. No, we're not going to integrate it. We're going to use the trapezium rule between 2 and 3. Now, when it says using 4 intervals, what it's actually meaning is sometimes you'll see the word strips, sometimes you'll see the word trapeziums. Notice how I'm spelling trapeziums. That will become clear later. So we're going to actually split it into 4 trapeziums. So it's this area that we want, that blue area there, and we're going to split it into 4 trapeziums. Right, so let's split it into 4. That looks like 4 intervals. They're going to be 4 trapeziums, so let's make them look a bit like trapeziums. Let's call them A, B, C and D. And of course, let's just have a think about what these values here are. So this must be 2.5 in there. This one must be 2.25. And this one must be 2.75. Okay, so that's what they're looking like. If we can find the area of the 4 pink trapeziums, we've got the blue area that we want. Okay, so area of a trapezium. What is the area of a trapezium? Here's any old trapezium. It's A plus B, so it's the 2 parallel sides added together, over 2, so we halve them, and then we times them by h, which is actually the width going across. So let's start ourselves off. We're going to start with trapezium A. So here comes trapezium A. I want this height. Now, how do I find this height? So I find this height by feeding the x value into the y value, and then that will give me that height there. So this height is actually the square root of 2. How do I find now this height? So this height will be the square root of 2.25, square root of 2.25, and then the distance between them is obviously the difference between 2.25 and 2, which is 0.25. Okay, so there's A. So let's pop him into the formula. He's going to be, the area is going to be root 2 plus root 2.25 over 2 times 0.25. Okay, there's my A done. Right, let's have a look at my B. So here comes my B into there. So my B is going to be this height. Now I've actually just found that height. It's there. So root 2.25 and then this height, which is going to be root 2.5. And of course the distance is going to be 0.25. So it's going to be root 2.25 plus root 2.5 over 2 times 0.25. Okay, let's move him up a bit. So let's do C. Here comes C. C is going to be the square root of 2.5. Then it's going to be the square root of 2.75. And that's going to obviously be 0.25. So square root of 2.5 plus square root of 2.75 over 2 times 0.25. And let's move him up a bit more. So D is going to now be, let's do D, here comes D. So square root of 2.75, square root of 3, and this again is 0.25. So square root of 2.75 plus the square root of 3 over 2 times 0.25. Okay, let's just move these out the way a minute. Okay, he'll go over there. Squeeze him up. Let's squeeze him up. In fact, we could move him down there, couldn't we? Right. Okay, so my 4 trapeziums look like this. I'm going to write it out now as a big long list. In fact, can you see all of them? All of them are divided by 2. And can you also see that all of them are times by 0.25? So what I'm actually going to do is I'm going to factorise out 0.25 and the dividing by 2 like that. Okay, then let's have a look at what we've got here. So we've got root 2 plus root 2.25. Then here we've got plus root 2.25 plus root 2.5. And here we've got plus root 2.5 plus root 2.75. And here we've got plus root 2.75 plus root 3. Okay, now if we have a look at that, but I'm just going to whiz him, oh no, he's right, move over, move over. So if we have a look at that in a bit more detail, can you see that this one is doubled and this one is doubled and this one is doubled? And the only ones that aren't doubled are the very first value and the very last value. So actually it would be much neater to write it as 0.25 over 2. Take this very first value here and the very last value here, and then instead of writing these ones out twice, we just write 2 lots of 2.25 plus 2.5 plus root 2.75. And that would be a much neater way of writing it. And it can all go into the calculator, which tells us it is 1.578 to 3 sig figs. Okay, we're going to start to formulise things now. This 0.25 here was the width of the trapezium. It would be very sensible to call it W, but actually what we're going to do is we're going to call it H for height. It's a bit weird, isn't it? So the way you're going to remember H is you're going to remember this guy here. Here she is. She's actually called Helga. If you ask me about Helga in the lesson, and I'll tell you a funny story about her. All right, so that's Helga. So H for Helga, H for height. It's not the height, it's the width. And then here, this bit here is the first Y value, isn't it? Yeah, that's the first Y value. This is the last Y value, and then it's plus 2 lots of the middles, meaning the middle Y values. And the reason that I've written these are the Y values is, do you remember I said trapezium? How do we spell trapezium? We spell it with a Y. So we are always interested in the Y values. All right, that's why I'm spelling it all the time with a Y. Okay, the most crucial question now, what do we write in the exam? So the first thing I'm going to say is you're going to draw a sketch of the graph. Now, I don't actually care if the sketch is right or wrong. It doesn't bother me in the slightest, but we draw a sketch, okay? So you just, any old sketch, it can always look like that if you like. And then we put in our values, so we're doing it from 2 to 3, and then you actually draw in the trapeziums, okay? So we're never ever going to get this wrong. So this is going to be 2.5, this is 2.25, this is 2.75, and there goes my trapeziums. Okay, so sketch first. Sketch, and then you draw in the trapeziums. Okay, now the next thing that you do is you're going to draw a table. Now often in the exam the table is given to you, so I'm going to draw the x values and the y values. So the x values are 2, 2.25, 2.5, 2.75 and 3, and most of the time the table will be given, but if it isn't you draw the table. And then we're going to feed in the y values. So we're going to go root 2, root 2.25, root 2.5, root 2.75 and root 3. So the formula is, area is, now this is a wiggly equal sign, which means approximately equal to h over 2, my friend Helga, big bracket, first plus last plus 2 lots of the middles, and then we do a big bracket to close. Okay, so h. Now the h you can see on the diagram is the height or the width. It's the width, Talk to me about Helga in the lesson. Okay, so the width, you can see it here actually. The width is 0.275. Can you, 0.25, isn't it? Can you really make sure you don't get that bit wrong? Because if you get your h wrong, the whole thing mucks up. You lose loads of method marks. First, now we're talking about y values. Now what I tend to do is I tend to circle the middle ones, and therefore the first y value is root 2. If you put x values in here, you will lose all your marks. So hence, do you remember I said trapezium? We are going for y values only. Plus the last y value is root 3, plus 2 lots of the middles. Here's the middles, here they are. So root 2.25 plus root 2.5 plus root 2.75. Close the bracket and the big bracket around, and then that can all go into my calculator, and that will give me 1.578. Okay, now a couple of extra things to talk about. That's basically it. That's how you're going to set it out. A couple of things to talk about. First, they might ask you to find this in the exam. So they might say find this between, what was it, 3 and 2. And they'll say using the trapezium rule, the trap rule. If you see them say that, it looks like you're going to integrate something. You're actually not. The minute that they say using the trapezium rule, they've just written the integral sign so that you know that you are finding the area under the curve between 3 and 2. But because they've said using the trapezium rule, you use our method here. Okay, so that's the first thing. The second thing that I want to say to you is this. They might ask you what would make your estimate better. So a better estimate would be this. I don't know, let's just say your curve looked a bit like this. A better estimate would be, can you see the trapeziums here? A better estimate would be if you actually increase the number of trapeziums, because it's going to match a bit more closely to the graph. So if they ask you what makes a better estimate, you just say increase the number of trapeziums, and you say thank you very much, examiner, that's 1 mark. The second thing, the next thing, is this. They might ask you if your estimate is an overestimate or an underestimate. Now, this is really dependent on what the graph looks like. So I'm going to draw you 2 graphs. One graph looks like this, and one graph looks like this. And we're going to put some trapeziums on. So let's pop some trapeziums. Now, if I'm careful and sort of slightly exaggerate it, can you see on this one that the tops of the trapeziums, so this is exactly what you'd write for your extra mark, trapezia, that's the plural, the tops of the trapezia are above the top of the curve, and hence it is an overestimate. The trapeziums are bigger than the curve. Now if we did this one, can you see, if I exaggerate it slightly, the tops of the trapezia are below the curve. Very badly drawn. So you would say the tops of the trapezia are below the top of the curve, top of curve, therefore it is an underestimate. Okay, so those are just a couple of little extra bits.